Good morning. So I hope you're here to hear about home automation in Kubernetes. This talk is a little bit of a lie, and I'll explain why, but bear with me. I joined a team inside of Google about 8 months ago, and their primary function is working on Kubernetes, Open Service Broker API, Kubernetes Service Catalog, and GKE. And for this talk, I want to focus on Open Service Broker and Service Catalog. And I don't really expect everyone to know what those are, but if you do, maybe the 5th time you hear about it, you might get it. We'll see. We work in collaboration with a lot of partners, including Red Hat, Azure, Dell, ASP, Cloud Foundry, and a few others that are that come and go. But these guys are the main ones. And as I was ramping up to the team, I saw a familiar pattern that these components could solve for me in a previous position. And I wanted to see if I could solve my past problems with the new tools, right? So I had a thought. What if I could use my home as an analogy for an on-prem deployment service? So I get Kubernetes to control my home. Sound premise, right? Because, well, I think it looks a lot like a hybrid solution. I think these components could solve some of the pain problems that I had in the past, and it's a little bit of fun, right? Like, who doesn't like using Kubernetes to change your home lights or whatever? So this talk is that journey to seeing if I could solve my problem. But it's also an analogy, which is the lie part. So here's what we're going to go over today. The basic idea, what I've been doing. I'm going to give you a quick overview of OSB API, and then Service Catalog. And then I want to preview some Google Cloud Platform Service Broker components, because I use them in my solution. And then we'll do a deep dive on what I actually built. So again, I wanted to use the cloud to control my lights. And so why did I want to do this? Because I have a Raspberry Pi running at home. It does all the local calls, but I'm pretty resource constrained. And that problem is a lot like I'm an existing company, and maybe we have a seasonal workload that needs to happen. And we've heard about this new thing called Kubernetes, or this new thing called the cloud. But we don't want to sacrifice everything we currently have. So it looks a lot like cloud legacy to me. So, right, like the legacy piece is limited resources. We don't really want to invest locally in maybe a seasonal thing. But we don't want to sacrifice all of our tooling that we already have. So maybe Kubernetes to legacy would be an interesting thing. But there's a little bit of an issue where there's not a good way currently, well, sort of, in generic bland Kubernetes, you can't really map legacy stuff into Kubernetes, because Kubernetes really wants to manage things that it's actually hosting. So that's where Service Broker comes in. And you don't need to know what that is yet. We're going to go over it. And now the problem becomes Cloud Broker, which is a little more manageable, because future talk. So the very general architecture that I ended up with was GKE, managed Kubernetes, talking with Service Catalog. And then Service Catalog talks to a broker, and then the broker talks to my legacy code and a light. So the components are K8s, which you should know about by now. It's day 3 of the summit. OSB API, which we're about to go over, and Service Catalog, which we'll go over next. So OSB API has nouns and verbs. So the nouns here are a service broker, right? It's the thing that you actually talk to from some platform. And the broker provides a catalog, which is the offerings, what it actually can do. A service offering is a type of instance, or sorry, it's a type of service. And OSB is interesting because it doesn't really define what this means. So in my case, it could be something strange, like a light. A plan is a derivative of that, and we'll go over this more. And then there's the verbs and what you can actually do. So I can ask the broker, hey, get the catalog, or provision a thing, or update, or bind. And so I keep saying service broker. The service broker is this, it's the way that you can, shim in front of something that you have that's custom, so you have to translate it into the OSB API, and the broker can host it, and then you can connect to it. Yes. And it produces these things, service instances. An instance gets a parameter set, and it produces a thing called a binding. So you ask the broker for an instance to produce a binding, and that thing comes back with a set of credentials. And then that's how you use to connect to that instance that you provisioned. And there's two ways you can really use a service broker. There's this way, which is maybe hosted black box. The broker is somewhere else on the internet. You've got credentials, you talk to it, you ask, may I please have a service? And it says, yes, here you go. It's somewhere on the internet. And you don't really know, and you don't really care, because when you bind to it, you get the credentials. And hopefully you have some way to network connect to it. And we're working on that piece, and that's coming later. Maybe in the next KubeCon we can announce a cool solution for that. So this is like a SaaS provider. So if you are an existing SaaS provider and you want to plug into provide a broker for other cloud providers to provision stuff, you put a broker in front of your SaaS interface that's currently existing, and all of a sudden now you're OSB API compliant. And I'll explain more what that means in a few minutes. The other way people use it, come on, buddy, is you launch, you actually deploy the broker inside of Kubernetes directly. And then it kind of gray boxes services back into your environment. Both are valid, both are defined, like, there's nothing against this setup either. So what's inside of a catalog? Service offerings and service plans. And a service offering is kind of a template of a class, but the definition doesn't really have to be that strict. And a service plan is a variant of that service. And again, the definition doesn't have to be that strict. So here's a result of my broker getting the catalog. I'm doing curl here, so it's just REST. So it's nothing super complicated. And here is how each verb interacts with that service instance. So it creates it gets the credentials. You can update the parameters if the broker supports it. You can unbind, which is to delete the credentials, lock it down again. And then you could deprovision, which means delete the instance. So I want to show you examples of like how we translate things between a couple. I'm going to have a couple examples, and I'll show you this translation. So in the Google Cloud Platform Service Broker for PubSub, Cloud PubSub, there's service offerings. So it's a topic and a plan, which they didn't really use, and a binding, which is a service account that gets to have rights onto that topic or a subscription to that topic. And so you can take a look at that. And then another for Cloud MySQL. The instance is the database. The bindings is an account that goes in, kind of write access or read access, depending on what parameters you set. And the bindings would be that credential block that comes back. And again, the verbs on how the OSB interacts. So for my lighthouse, I decided that a service offering meant the room that light exists in. And so in my mind, a light was a service, like a thing that runs somewhere. But the plan is the type. So in my exact example, I have a bunch of rooms, and then I have colors, because I made a cute Copenhagen-themed demo board, which we'll turn on in a couple minutes. So those are the nouns. Oh, sorry. And a binding is it's a credential. So in my case, it turns into a token that I'd use on the API. So a bit of authentication, but I've abstracted the authentication away. And so to provision a service class here is to reserve a light. To bind to it would be to get that credential. And I've made a limitation where my broker, the way it's implemented is you can provision each light once and you can bind to it many times. And I have a manager that watches for tokens on the API, and it redirects it and turns it on or off, depending on what the parameters came in. And so to unbind would be to delete that token, and to deprovision would be to reset the light, release it. So quick service catalog. This is going to be super quick. Feel free to ask questions. So you have that service broker, and it may or may not be inside of Kubernetes directly. And then service catalog is running inside of Kubernetes as and it's part of the aggregated API. It's an API server, so it extends Kubernetes with some new nouns and verbs. So you get some new resource types, and then you can do things on those resource types that translates into OSB calls. And that's really all that service catalog does, is it maps the imperativeness of Kates to the declarativeness of OSB API, which isn't an exact match for Kubernetes, but it kind of works. And then the actions of OSB API is if you would like to produce a provision, you would create a service instance, which is a Kates resource. And then you could change the parameters, which may result in an update if that's supported. And then unbind would be, to bind would be to create a service binding and you give it a reference to that service instance. And then to unbind and to deprovision would be to delete those Kates resources. And those eventually trickle down, and service catalog's job is to watch for changes and then translates those directly into REST calls to the broker. So we just launched Google Cloud Platform Service Broker into beta I think maybe last week. And because I used it in the talk, I figured I should kind of give you a preview of some stuff. Here's a wall of text from the blog post. You can go check that out. But basically what it does is it provides you so Google GCP provides a bunch of APIs that you can create stuff like PubSub, Cloud Spanner, things like this. This is what we currently support, and more are coming as we turn on more APIs. So why would you use this? It's a good question. So this is an example deploy script in GKE to deploy a simple application that provisions an instance of PubSub, binds to it, and then passes those credentials into the simple application. And let's say you run Kates on-prem. This is the same script for doing it on-prem. So this is the benefit of OSB API and Service Catalog. If you tie the two together, your deployment scripts are exactly the same, assuming that you have that same broker inside of your Kubernetes. Let me do it again. Watch for the change. All right, it's pretty cool. I think it's pretty cool. So if you want to learn more, here's a URL. This is mostly for like the printout. Okay, Now that we got that out of the way, we can talk about the LED house that I made. I called it LED house. I didn't really feel like I wanted to bring a bunch of lamps and stuff on the stage because I was 100% sure that that would not work as a demo. So, okay. So again, I want to use the cloud to control my lights. And we've already talked about how my lights are really OSB. So it's the cloud controlling some OSB endpoint, which now is a very simple problem because it looks like this. Because we have the tools for Service Catalog. Service Catalog knows how to speak OSB API. And I just have to write the logic behind the inside of my custom broker that speaks OSB API. And hybrid could look like this, right? You've got your K8s cluster running Service Catalog. It talks to a service broker, talks to your legacy controller, whatever that is, maybe Puppet. Maybe it's a bunch of shell scripts. And I thought that looked like home automation. So I figured it's a good match. So you want to see it working? Let me turn on this. So I've got to run a couple things that are local. Okay, and refer to my notes here. So I'm going to okay, so because we added custom columns, there's another tool called SVCat. You may have heard about it. It's basically using kubectl, but it extends it and then makes the formatting a little different. And it's going to be a plugin if the plugin story can be actually usable. But I'm going to use SVCat directly. I'm going to, hold on, I'm going to read. I think I need to ask for a fresh catalog. Oh. So in my, cool. So now I can do SVCat. And I see that, so this is SVCat get, is the class, the offerings. And I have two brokers installed. SVCat. So I have this, the GCP broker, which is a host one, and I have a broker proxy, which is actually injected inside of my K8s cluster. And I'll explain more about that later. So I want to provision one of these. I want to take out, so okay, this thing is, it's floors, 1, 2, 3, 4, and then A, B, C, D, or ABC. So 1A should be the lower corner. I'm going to take the red light, because that's the plan, and then I'm going to get a binding for it. And then I'm going to deploy this, yes. So now I have an instance of A1 red, which is class 1A, which is the room, and its plan is red, right? So that's my abstraction. And I'm going to deploy a demo. And this is a little simple application that has a service. Okay, sorry, okay, I didn't explain this, but OSB API uses overloads of the term service. So we don't mean like the proxy, like the Kubernetes service. It's actually like the app. It's a little confusing. Oh no, what? Demo, live demo. Why are you doing this to me? Get out of there. Maybe I could just apply it. Okay, so that should be launching and doing its thing. We can confirm that. So there's a new thing, cool. And then let's see what URL it's at. I dare you. Yeah. So I made a very simple application, hopefully. Oh no. Oh shoot, okay. Well, let's move on to the better demo. I'm short on time. Okay, so, thank you. So if I wanted to extend functionality, I could launch an application inside my house and then push it back up to the app that's running in the cloud. So this is the hope, right? Like I extend functionality, I can do different types of, maybe I have multiple service brokers that interface to multiple devices in my house, and I can pull those back up into Kubernetes in the cloud and then do complex integrations there. And so I know what you're thinking. It sounds like a real bad idea to connect your house to the internet, and I agree. So really you wanted this, but in reality, I don't really want my house to be able to talk to the cloud, or the cloud to talk to my house. So I need some sort of bridge. And for that, I use PubSub. I use the GCP broker to create instances of PubSub. And it connects. And because I used OSB API, I actually was able to just shim in the broker proxy. It takes requests, it bundles it up, puts it on PubSub, takes it down, makes a curl call locally, and then packages the response, puts it back on PubSub, and then the service catalog doesn't know the difference between talking to a local one or talking to a hosted one. So that was neat, and so I figured out I could do some pretty weird things with this thing, and I open sourced this. It's on my GitHub page, and if you want to see the trace, it makes a bunch of calls, and then that response comes back. And eventually, Kubernetes, you can get the status for it. So notice that the kubectl side doesn't have to wait for all of that magic to happen. And that's the ops plane, and the control plane. I did a similar thing. Application actually just talks directly on PubSub. So I wanted to give a cool demo. Let's see if it. No. If you could do me a favor and get ready with your Twitter devices. And I have to do some creating of services. So what I'm doing is I'm making an instance of every light that my board has. And now I'm going to make an instance of, or a bind to every one of those. And hopefully we have a couple seconds. And then I'm going to deploy this guy. Oh, yeah. Okay, so I made a Twitter scraper. Oh, come on, man. Let's try it again. Okay. So I think if you tweet this format, the lights should turn on. And so I have a complicated app running in GCP. It talks to PubSub down to my laptop at the conference center, and there's a Arduino up here talking to the board. So did it turn on? Oh, come on.
Where can we tweet you?
Just anywhere. It'll watch all of Twitter. It's looking for LED house. Exactly. Did it work? Anyone?
Still typing. I'm not getting anything.
Shoot. Well, pretend it worked. It was great. Oh man, that's a bummer. Well, live demos. So anyway, if it worked, it did work in the conference room yesterday, and it turns on, and it's cool. So maybe you see me later, and I'll get it working. So there's some Git repos to get you started. So I actually built LED broker based on OSB starter pack and OSB broker lib. Broker lib gives you just the hooks to implement your business logic. It's very fast, it's Go based, and then you figure out how to get it up and running, whatever that means to you. Thank you. I think maybe time for a couple questions, if you have them.
So you talked about how you might have the service inside the cluster.
Yeah, here.
So you talked about how you might have the service running inside the cluster, the broker creates something inside the cluster.
Yeah.
We've heard a lot about operators over the last few days and why you might create an operator for Postgres or whatever.
Yeah.
How do you think these things relate? Do you think
Yeah.
would
So
want to use one?
an operator would be very similar to that thing. What the operator doesn't get you is to be able to bind an external black box service from a SaaS provider on the internet somewhere.
But so I think my question is does this work well with an operator? Should you use Service Broker with operators for that sort of thing, or is that just overkill?
Well, they just announced it a couple days ago, so I need to go back and actually see what they open sourced. So it might be that it's a good candidate for certain types of brokers, and maybe an easier way to do those the verbs on OSB API. So yeah, it's interesting, and we might do something with it. Why didn't it work? So I don't know. What?
So what happens when your Twitter scraper gets something that it wasn't expecting?
It should just dump it.
Okay.
It shouldn't do anything. Did it ever work? No. I don't know. Maybe I'll set it up at the Google booth. Maybe go there after if you want to play with it. So thank you.